Oh, he did.
All right. In this example, ladies and gentlemen, when we are looking at applying the rules of exponents, there's a difference that we're going to get into for day 2 rather than day 1. In day 2, please don't do that again. In day 2, what we were basically looking at was applying the rules of exponents. Or in day 1, we were looking at that. Here, you guys can see we have expressions. Now we have included expressions where we have terms that are separated by addition or subtraction. So the first thing we're going to do here is we're going to have a little bit different. You guys can see we don't have any exponents, right? So to simplify these, the first thing we're going to have to do is we're going to want to make sure we can simplify our numerator and our denominator by factoring. All right. Now remember, this is the big thing that I was having some trouble with some students, is when we're going in for factoring, ladies and gentlemen, remember factoring is basically rewriting something as a product. So can I rewrite the number 6 as a product? 2 times 3. And what I want you guys to understand, C9, if you can't sit there and pay attention, then we can find a different seat. If 6 can be rewritten as 2 times 3, what I want you guys to understand is 6 is like the area, and 2 times 3, the factored product, is like the side legs, right? So if I want to be able to factor this, I can say, all right, what about if I said 3p plus 9? Is there a side length? Could I have 2 as the side length for this?
Yes.
2 times what would give you 3p?
6.
It's going to be some fraction, right? And we don't want to be dealing with fractions. What would be maybe a better side length for me to choose instead of 2? What about 3? 1 is always going to work, right? 1 is always going to work. So we're not going to want to choose 1. We're going to want to choose something other than 1 because 1 always works. So 3. If I say my side length is 3, 3 times what gives me 3p? P, Kelsey. 3 times what gives me 9? 3. So would you guys agree with me that 3 times p plus 3, would you guys agree with me that 3 times 3 plus, or p plus 3 is the same thing as 3p plus 9? Yeah. It's the same thing. Do you guys agree with me that 2 times 3 is the same thing as 6? Yeah. Yes. But this is what we call our factored form. Yeah. So what I do is I rewrite this in the factored form. OK? Now that I write this in the factored form, we need to go through one last property.
Wait like 2 seconds before you go through
OK.
the last property. Did you time him for real?
Every day.
So the next thing that we do is, last thing I want to cover with you guys, if I said 3 divided by 3, you guys should be used to 3 divided by 3 is 1. If I said x divided by x, that's equal to 1. So then what do you guys think of x plus 3 divided by x plus 3? What do you think that will be? 1, right? When you have the same thing divided by itself, it divides into there one time. So p plus 3 divided by, I don't need these parentheses, divided by p plus 3 is going to equal what? 1. So my final answer is just 3. Yes?
So what if it's like x plus 3 over 3? Would it be like 1x? We're talking about the bottom, the example you gave.
Yeah?
Where's that second x? So would it just be like 1x?
That?
Yes.
No, you cannot do that. This, it could be left as x plus 3 over 3. That divides into both of them. These do not divide out. These do not divide to 1. Because the 3 has to be divided into both of those numbers. But when you have it as an expression, this is an expression over expression. These are the same terms, so they divide to 1. OK? For instance, if